is natural products and drug discovery. So, natural products play a major role in drug discovery, and you can say that nearly around 60 to 70% of the approved drugs in the market, they are either natural products or natural product derived, or the inspiration of the drug structure comes from the natural products. And all of you know about a very famous example, that is a paclitaxel, and the paclitaxel is one of the one which is isolated from Pacific yew tree. You see that this is a paclitaxel structure, and this is a Pacific yew tree, and the barks of the Pacific yew tree is being used to extract the paclitaxel. Okay. So, this is the tree when all the barks has been removed. So, if you see that when all the bark has been removed, this is how the Pacific yew tree looks like. Okay. And as many of you know that, so these natural products, are they primary metabolites or secondary metabolites? Oh, many of you are aware that the primary metabolites are basically DNA, RNA, proteins, carbohydrates, lipids, nucleic acids, and nucleic acid, RNA, DNA, proteins. These are all basically primary metabolites. The secondary metabolites are basically these type of small molecules, or the secondary metabolites which is arising from the natural products. So, as a biotechnologist, if you keep on what you call removing the barks of the paclitaxel, okay, what may happen to the tree? So, the tree may die after some time. So you lose your precious resources of your drug molecule itself over a period of time, because all of these are basically, they do not have in what you call in the infinite quantity. Okay. These are all basically going to they are not going to last forever. So, they are going to lose their what you call after, when you are having a over exploitation of natural resources, they are going to go away from the entire face of the earth. So, as a biotechnologist, what you may want to do it? As a biotechnologist, what you may want to do is, can we use or can we find out what are all the metabolomic pathways which will be able to synthesize these type of molecules. So, that is the one of the way to use. Not only paclitaxel, see one of the other drug, that is basically artemisinin, that is for the anti-malarial drug, is used in the Chinese medicine, which was also Nobel Prize was awarded. So, that also comes from a plant source. Like many different one come from a plant source, and this is important to know. The plant sources, over exploitation of the plant sources is going to be extinction of the particular tree or plants and etc. So, we need to be extremely careful in over exploitation of our natural resources. For that, understanding of the metabolomics will help the biotechnologies to create pathways and to create a biotechnology ways to synthesize all these secondary metabolites. So, now the next one, I am just going to show you the another important one. So, for the what do you call, I will say this is the book which was published by Wiley, Natural Products Isolation, Structure and Elucidation. This is the ISBN number. You can get the book, e-book, and you will get it. You can go through that. In this book, I am just going through the only one of it. Okay, only one of it. That is the first chapter. Okay, which talks about what is the compounds present in pomegranate. Okay, so pomegranate, as many of you know that this is very antioxidant property. So, pomegranate basically moved from India to Persia and towards all the western countries. So, now is grown many of the countries, especially in the Middle East as well as Afghanistan, India and Pakistan and etc. So, it has many antioxidant properties. it is known for their antioxidant properties. And these are the molecules are present in the phenolic compound present in the pomegranate. As many of you are aware that they have antioxidant properties because of the phenolic compound present in that actually, because they get oxidized, so that the reactive oxygen species will get killed by the oxidation of these molecules. So, this is how the antioxidant property of pomegranate juice or pomegranate works. And many of you are aware of it, the root bark of pomegranate contains this molecule as pseudopenetrine. Okay. This one of the drug is used in the western medicines, and this is a root bark of the pomegranate. And you please go through this chapter alone, only this chapter, first chapter from this book, okay, first chapter from this book, please go through that and prepare the questions, only the first chapter on the isolation of all these molecules in this one, okay, you see, and prepare the questions answer for the so prepare the answers for the questions present in the particular chapter, only chapter 1, not any other chapter, only the chapter 1 from that book that talks about the pomegranate and pseudopenetrine, okay, penetrine, okay. This is the only thing we are talking about. So, in the olden times, you take aspirin is inspired from aspirin is inspired from the natural product, and this acetyl salicylic acid, okay. So, this is inspired from a natural product. So, natural products inspires many chemists, medicinal chemists to make many drugs. So, isolation of the natural product to identify the structures is the important compound in the 1950s and 60s. Even now, so many antibiotics are isolated from the soil sources, from isolated from metabolites and etc. Okay. And for that one, we next experiment involves with the isolation of curcumin from turmeric. Okay. So, you will see that this experiment is being done for the isolation of curcumin. You see here, I have given the structure of curcumin. I have shown the what is the tingle was being used. So, you see here, you packed your turmeric powder in the socket, which is present in the sock salt apparatus. So, this entire thing is basically the, so you have entire this setup is basically the sock salt apparatus. The sock salt apparatus, in this place you pack your turmeric powder and keep it, and add your dichloromethane in the heating mandle and the round pot of flask, you fix it with here and you just make it to boil. So, when it is getting boiled, so it gets, and you have in the top you have a condenser, cooling water coming and cooling water going out. So, you have a condenser. So, the solvent, it gets boiled and it goes out and comes down, it extracts many molecules present. It is a slow extraction, it is getting possible. You can see here, so there is a, so one tube, okay, you can see this one very clearly, okay. This is the tube where from which you have the solvent will evaporate and go up and get condensed and come down to the particular one, okay. So, you pack the turmeric powder and kept it here and that get extracted. So, you keep building the pressure and also it slowly accumulates, the solvent getting accumulated, and in this case the bottom one here it's keep on depleting the solvent. Okay, after some time it get depleting the solvent. So, because you are keep on pumping, right, after you keep on pumping, it will solvent get pumped a little bit. But now what happened after some time? So, after some time, due to the pressure of more, so it builds up the pressure. So, due to the pressure, so whatever the solvent, the amount get extracted by the solvent, so it comes down completely to through this setup. Okay, through this setup. Okay, it comes down to the round bottom flask. You see the difference in this one, it get evaporated, and after some time, let us say the continuous extraction of the boiling of the dichloromethane, and after continuous boiling and going through the entire setup, and you will see that after some time, due to the pressure building up in the dichloromethane, so the entire solvent got collected here, will drained out through this setup. That is the beauty of sock slit. So, the sock slit is being used to continuous extraction. So, now the solvent, you do not have to use more and more solvent, right, because the now solvent is whatever solvent you had again comes back to the same level. Now, again solvent gets evaporated, only the solvent gets evaporated, it goes to the socket and it cools down, extract the curcumin, and after some time and again it's bring down the dissolved compounds into the round bottom flask. So, this procedure is repeated for nearly for 3 to 4 hours. Okay, so that you will get a better extraction of the compound with the low amount of the solvent. Okay, you have a better extraction of the solvent with the low amount of solvent. That is the reason we are using the sock slit apparatus. So, what will you now, how will you isolate the compound? Very easy. Now, we have used only the dichloromethane, the simple extraction, the dichloromethane. So, the dichloromethane is being extracted, and you have a round bottom flask. You take the round bottom flask directly to the rotary evaporator and evaporate all the solvent, and you get your curcumin in a pot. But curcumin has 3 different isotopes, okay, isomers, I won't say isotopes, 3 different isomers, and this is the NMR of curcumin. So, you will see here, you can see here, there is a possibility of what do you call tautomer, because of what do you say, active methylene present in this CH2, and it will get form a conjugated bond, and it may form the enol formation. So, it may have a enol formation, or it may have this type of one. Okay. So, if you look at this one, you see a peak at 3.8 here, okay, 3.8, and many of them are present. You will see here 1, 2, 3, 4, 5, 6, 7, 8 peaks are there, okay, and 3.8 you see nearly for 6 of them, okay, nearly for 6 of them you see and this one you may not see at all, because you do not see the if you look at all of them, so there is for this is about for 2 protons, let us say this is for 6 proton, comes for this 2 OCH3s, okay, and if it comes for this 2 COH3s, this for 6 protons, then this is for 1, 2, 2, 2, 2, it's about 2, it's about 2. So, 2, 4, 6, 8, 10, 12, 13, 15, and another one is about here 16. So, if you are trying to find out where the 16 are present, okay, you can see that there are 1, 2, 3, there are 6 aromatic ones, okay, seven, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 1, 2, 3, 4, 5, 6, 7. Yeah, it exactly matches. So you have about 12, 13, 14. So what are you seeing at about 15 corresponds to the basically the phenolic the what do you call the tautomeric position, and which is enol formation. Enol formation comes between anything between 12 to 16. That's what you are seeing it here, and all other peaks you see it at various positions. This enol one comes at various places. You will see that two OHs coming at, and various some of them are coming at various places. So this is how the NMR is isolated and it got purified and etc. Okay. So this is the NMR of NMR of curcumin. So curcumin is used in various our culinary things, and because of it has antioxidant properties, it's good for our health and everything. Okay, and it's followed by this. There will be a video, and you can go through the video. This is a simple extraction procedure, and the video will show you very clearly how the Saxford apparatus was arranged, how they are packing it, how the extraction is done. After the extraction, so the solvent was taken through the rotary evaporator is being evaporated, and you will get your entire compound after drying, etc. Okay. So this is how the curcumin is isolated from the turmeric. Okay. So this concludes our third experiment, and we will see our fourth by tomorrow. Okay. So let me
weigh 20 gram of turmeric powder and transferred to a extraction thimble. Place the thimble in Soxhlet apparatus. Add 200 milliliters dichloromethane to a round bottom flask. Assemble the Soxhlet apparatus and reflux for 1 hour. The extraction was monitored using TLC. Finally, a reddish-yellow oily liquid was obtained after extraction. concentrated the crude in rotary evaporator to obtain the curcuminoids.